Good afternoon. Metabolic acidosis versus respiratory acidosis. How do we discriminate between the two conditions? I make this video based on responses by several students in recently concluded vivas I was part of, that in diabetic ketoacidosis, the student said there is Kusumul breathing, deep and fast breathing, etc., etc. So therefore, it is a case of respiratory acidosis, which is absolutely wrong answer. It is a case of metabolic acidosis. So with the help of this condition, diabetic ketoacidosis, we would try to discriminate between metabolic acidosis and respiratory acidosis. Now, first, let us see this Henderson-Hasselbalch equation. Let us examine this. pH is equal to pK. pK, it's a constant, 6.1. Bicarbonate concentration is numerator, 25 millimole per liter. And partial pressure of carbon dioxide, mean value, 40 millimeter of mercury. And this is multiplied by a constant 0.23. And this 6.1, this pK, as we discussed, this is actually a constant negative logarithm of dissociation constant of carbonic acid. Let's forget about it. So the most important part in present discussion is that it is the ratio of bicarbonate and PCO2, which is variable, which are variable factors in this equation. So change in the ratio can cause acid-base disorder. pH means, acidosis means fall in the pH. This can occur because of two causes. Either there is fall in the bicarbonate concentration, either fall in the numerator, that is bicarbonate, or elevation of denominator, that is PCO2. So fall in bicarbonate or elevation of partial pressure of carbon dioxide, both are capable of decreasing the pH value. When primary defect is fall in the bicarbonate concentration, primary cause of acidosis is fall in the bicarbonate concentration, then we call it metabolic acidosis. Conversely, when raised PCO2 is the primary cause of fall in the pH, then it is respiratory acidosis. So fall in the numerator, metabolic acidosis. We return to diabetic ketoacidosis. Why we call it metabolic acidosis? In other words, simply stated, why there is fall in the bicarbonate concentration from normal value of 25 millimole per liter. In ketoacidosis, excessive generation of ketone bodies are there. Acetoacetic acid, beta hydroxybutyric acid. So they are all acidic products and therefore proton donors. Acid means proton donor. So excessive generation of H plus will be there, which will be neutralized by bicarbonate ions in the extracellular fluid, resulting in formation of H2CO3. Further events we won't discuss, बस अभी इतना ही काफी है. If there will be fall in the bicarbonate concentration, because the bicarbonates will be depleted for neutralizing the protons. So fall in the bicarbonate, and that means metabolic acidosis we had already seen. So metabolic acidosis in diabetic ketoacidosis, because the primary defect is fall in the bicarbonate concentration. We started the class with the Kusumul breathing. Let us talk a bit about that also. You see, there are certain compensatory mechanisms they come into picture. क्योंकि pH को अगर दोबारा से restore करना है, so then this ratio has to be restored. So primary defect was fall in the bicarbonate concentration. How can you restore this ratio? By decreasing the PCO2 as well. So PCO2 wash off करने के लिए क्या जरूरी होगा? Hyperventilation, deep and fast breathing, that is called Kusumul breathing. So that is, we have discussed about why it is metabolic acidosis. Now you see, although not a topic today, let me talk a bit about respiratory acidosis also. In respiratory acidosis, as we said, that the primary defect is what? It is raised PCO2. All right. So increase in so that can be compensated. The ratio can be reverted back to the normal by elevating the bicarbonate concentration. For that, certain renal mechanisms come into picture, which is beyond the scope of this class. And lastly, just to conclude, respiratory acidosis, as we said, primary defect is raised in the PCO2. वो कब होता है? In respiratory insufficiency, for example, pneumonia, fibrosing alveolitis, and the recently concluded, I hope concluded pandemic, COVID-19. वहां पर क्या था? Respiratory insufficiency, PCO2, which took so many lives. And then some other causes, respiratory insufficiency, obstruction in the airways, chronic obstructive airway disease seen in smokers. Number 3, in the muscular weakness, for example, in poliomyelitis, tetanus, the thoracic muscles become weak. Or fourth cause, the thoracic cage may become weak. For example, in scoliosis, flail chest, etc. So all these will lead to increase in the PCO2. And as we said, increase in the bicarbonate concentration, compensation. We will talk in some other lecture. At the moment, we have discriminated between metabolic and respiratory acidosis. Metabolic के अंदर the primary defect is raise in the bicarbonate concentration compensated by decreasing PCO2. Respiratory acidosis, the primary defect is raised PCO2, which is compensated by elevating bicarbonate by renal compensatory mechanism. Some other time we will discuss. Thank you.